In this tutorial, we will talk about different number systems used in computer science. You're familiar with the decimal system, a base 10 system. We also use binary, which is a base 2 system, for storing information on a computer. Remember, computers can only store zeros or ones, which are electrical pulses, 0 meaning off, 1 meaning on. That is how information is stored. We also use octal, which is base 8, and hexadecimal, which is base 16. The decimal system, or base 10 system, has 10 digits available for every digit in a number. Let's count in decimal. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I've used all of my 10 digits, so I'm going to put 1 in the tens place and start back over at 0. I have 1 10 and 0 ones, making 10, 11. So let's look at this number in detail, 3,207. The first column is 10 to the 0. The second column is 10 to the 1. The third is 10 to the second. And the fourth is 10 to the third. So the first column is our ones column. Our second column is our tens column, our hundreds column, and our thousands column. So when I break this number down, I have 3 1,000s plus 2 100s plus 0 10s plus 7 ones. And when I add those together, I get 3,207. Let's look at the binary system, or base 2 system. For each column, we have 2 different digits, 0 or 1. So let's count in binary. 0, 1. Well, after we've run out of digits, we have to move over to the 2's column. So we'll put 1 in the 2's column, and then we'll start over at 0. So 1 0 binary is the equivalent for 2 decimal. So when I add one more, I have 1 in the 2's column and 1 in the 1's column, which gives me a total of 3 decimal. So if I add one more, I have to move over now to the 4's column. So I have 1 in the 4's column, 0 in the 2's column, and 0 in the 1's column for an equivalent of 4 decimal. 5. So let's look at this number 1101, which is a binary or base 2 number, and let's convert it to decimal. This is the 2 to the 0 column, 2 to the 1, 2 to the 2, and 2 to the 3. So the first column is our 1's column, and then we have our 2's column, our 4's column, and our 8's column. So in this number, we have 1 8 plus 1 4 plus 0 2's plus 1 1 for a total of 13 decimal. Now let's look at base 8 using the same principles. Base 8, we have 8 different digits, 0, 1, 2, 3, 4, 5, 6, 7. So when we've used all of our digits, we have to put 1 in the 8's column and then start back over at 0. So 1 0 in octal is 8 decimal. 9, 10, 11. Let's look at this octal number and convert it to decimal. This is the 8 to the 0 column, the 8 to the 1 column, and the 8 to the 2 column. So the first column is our 1's column, and then we have our 8's column, and then we have our 64 column. So to convert this number to decimal, I have 164 plus 4 8's, which is 32, plus 3 1's, which is 3, for a total of 99 decimal. So in octal, the number 143 is 99 decimal. Now let's look at hexadecimal, or base 16. Base 16 means that we will have 16 different digits to work with in each column. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, well, if I have 16 digits in the first column, what will be the next number? 9. Since we've run out of numbers to use, we are going to begin using letters. So 10 is represented by the letter A. 11, 12, 13, 14, 15. Well, when I've run out of digits, because I've used 0 through 15, which is 16 different digits, I'm going to put 1 in the 16s column and start back over at 0. So this is 16, 17. So our first column is 16 to the 0. Then we have 16 to the 1, 16 to the 2, and 16 to the 3. So our first column is our 1s column, and then we have our 16s column, and our 256 column, and our 4096 column. So if we take this number and convert it to decimal, we're going to have 1 4096 plus, and then remember A represents the number 10 in decimal. So we're going to have 10 256. So we have 4096 plus 10 of the 256, which is 2560, plus 3 of the 16s, which is 48, plus 1 F, and F represents 15. So if I add all those numbers together, I get 6,719 decimal. So let's flip it around and convert a decimal number to a different numbering system. First, we'll convert to binary. So I have decimal 39 and I want to convert it to binary. So I'm going to divide the decimal number by the base that I'm converting to. Binary is a base 2, so I'm going to be dividing by 2. 39 divided by 2 is 19, and I have 1 remaining. 19 divided by 2 is 9, and I have 1 remaining. 9 divided by 2 is 4, and I have 1 remaining. 4 divided by 2 is 2, and I have 0 remaining. 2 divided by 2 is 1, and I have 0 remaining. So I know I'm finished when the number I end up with is a number in the base system. So if I end up with either a 0 or a 1, then I'm finished. So now to convert this to binary, watch how the numbers are placed. I'm going to start at the top number, and that's going to be the rightmost digit. Okay, and there is our binary equivalent for 39 decimal. I have my 1s column, my 2s column, my 4s column, my 8s column, my 16s column, and my 32 column. So when I add up all those numbers together, I have 32 plus 0 16s plus 0 8s plus 1 4 plus 1 2 plus 1 1, which gives me a total of 39 decimal. Now let's try the same thing converting to the octal base. Remember, octal is base 8, so I'm going to take my decimal number 139 and divide it by 8 to convert it to octal. So 139 divided by 8 is 17, and I have 3 remaining. 17 divided by 8 is 2, with 1 remaining, and since 2 is a number within the octal system, I'm finished converting. So I'm going to take that top digit and put it in the rightmost place. So 139 decimal is the equivalent to 213 octal. I have 3 1s, 1 8, and 2 64s. And if I add those together, 128 plus 8 plus 3 is equal to 139 decimal. So in conclusion, you've learned the different systems that we're going to be using in computer science. You're familiar with the decimal system, or base 10. You've learned about the binary system, base 2, octal system, base 8, hexadecimal system, base 16. We've learned how to convert from another base to decimal and to convert from decimal to another base. You can also look online for additional practice for converting from one base to another.